Let's see. All right, so yeah, we should be live now. Are you gonna go live on your channel as well?
Yes.
All right, great, great.
Trying to get
So,
that worked out now.
no problem. Take your time. I wanted to actually start off. Okay, the sound is good. So I wanted to actually start off by maybe getting to know each other slightly. You know what I mean? Before we start getting into the exchange of ideas, which can get a little little combative. So I wanted to start off by asking you where you're from, if you don't mind.
Where I'm located, I'm in Austin, Texas.
Okay, okay. Is that where you're originally from, or are you
I know I'm originally from New Orleans.
from New Orleans?
That's right.
Okay, okay. Very, very good, very good. What do you
That's
do if you
where
don't
I
mind me
was
asking?
born.
I said, what do you do if you don't mind me asking?
Student. I'm a full-time student. I'm still working on this stream thing here.
Oh, okay, okay,
I'm
okay.
working
Take your
on
time. Go ahead.
my bachelor's degree in physics, and I'm
Ah,
adding astronomy as well. So
okay.
still seeing if I'll finish with physics, but I'm working on at least a bachelor's degree in physics and maybe astronomy as well, at least astronomy and maybe physics as well. So that's where I'm at right now.
Very good, very good. I actually started off my college career in physics, and I quickly
Oh, hold up.
switched to political science.
Having some feedback again. Let me see how this.
You getting
There we
feedback
go.
from your
Can you
side?
still hear me?
I can hear you good over here.
Sorry, what were you saying?
I was just saying that I actually went into school initially as a physics major, and then quickly switched to political science, like within like my first few weeks of being at school. So yeah,
Interesting. What made you switch?
um, just me thinking about money. You know, I honestly didn't even really want to go to school, but my parents weren't giving me any other options, so I wanted to start working right away and figure out how I could start some businesses. And so I was interested in physics, so that's why I initially went into it. But then once I went to school, started talking to counselors, and started figuring out what I would be able to do with it, I was like, all right, this is out.
Okay.
Yeah, yeah. Yeah, what about you? What you already have an idea of what you want to do with your degrees moving forward, or not yet?
Yeah, I'll be a college professor. May do some research. I had some minor, I guess you can say, research experience with NASA, this community college thing that they have. So that was pretty cool. So I was able to interact with some of the NASA folks and learn a bit about NASA and what they're doing. I applied for another internship with them over the summer. So it's possible that I may be. I mean, that's a potential to be working with NASA in the future, but
Right,
my
right.
focus is on being a professor.
Nice, nice. So you're don't take this the wrong way. The name of my channel, by as you can see, is Real Offended, right? And the
Mhm.
reason why that's the name of my channel is because it's literally impossible for me to be offended by anything or anybody. And so because of that, I'm constantly offending people with just me and my normal state of being. And so I always encourage people to not take anything I say personal, but also don't hold back. If there's something that you want to say to me, if I say something that sounds crazy to you, you know what I mean, you can feel free to give me a what the, you know what I mean, or be like, all right, bro, that sounds ridiculous, you know what I mean? Because trust me, if you say something that I find crazy, I definitely am going to uh definitely am going to bring it up. So you said you work for NASA, and your
No,
plan is
no,
to
no, no,
be.
no, no,
Oh
no.
no, no, my
What I
bad, my
said
bad.
was
You had an
I'm a
internship.
student. Yeah, yeah, exactly. It
Sorry
was
about
sort
that.
of a learning opportunity. Even technically was less than an internship. It was more of a learning opportunity.
Okay.
But it opened the door for that being an option after a few more steps. I applied for an internship with them, but no, I don't work with NASA. I don't want to. I'm not saying I
Right,
wouldn't like
right,
to, but I'm just saying that's a pinnacle that I have yet to reach.
right,
I just
right.
want to make sure nobody is mistaken on that. I don't want to falsify my credentials or whatever.
Right, right, right. Yeah, no, I got it mixed up. I forgot you had said that hopefully it would be a dream one day to work for NASA.
That would be something I would if I had the opportunity, I'm pretty sure I would take it. I'll put it that way. I can't
Nice,
say it's a
nice.
major focus, but it is on my radar. And I did do the I'm an alumni of the NCAS, it's the Community College Scholars initiative that they have. and
Very
I'm gonna
cool. Very
stop
cool.
filling it with my cream thing and be more focused. So I just leave it the way it is. But yeah,
Interesting.
but right now, what I'm really doing is I'm mostly a student.
Okay, cool, cool. All right, so let's get in a little bit deeper. So I mean, just based up off the career path that you are heading toward, this doesn't necessarily mean that this is true, but based off the career path that you're heading toward, and based on what I've heard so far, you seem like the type of guy that pretty much buys into the mainstream story, right? When it comes to what's going on in the world, what we currently know about I guess science in the world and particle physics, what we know about the cosmos. It seems like you were probably the type of person that has faith in that has faith in the information apparatus that allows us to receive and not receive other information. You believe that is
Well, put it like this: before we even go down that stream, because I know we have a limited amount of time.
right,
I
right.
would actually really like to hear from you. I was not like being facetious in my request, like you had said in your when you were debating. Who was it you were debating?
Leo,
Leo Fidus,
yes,
that you welcome anybody to come talk to you who might disagree. And you have
right,
said in the chat that you are uh, uh, well versed on gravity, and that's one of the topics
yeah,
that I wanted to discuss with
absolutely,
you.
yeah. We,
So
we can Yeah, well, we can get
go
right
ahead.
to gravity. That's why I have these resources right here set up. And I wanted to ask that question first because like without going too deep into it, we have to understand that a lot of the stuff that we think we know are built on top of like quote unquote a house of cards, right? Just to put it as simply as possible, right? Most of what we know and think we know is a house of cards, right? So we think that we know this is true because of this, because of that, and that. And then when you go all the way to the bottom, you realize that the actual foundation that our quote unquote scientific theories are built on doesn't have any
Mhm,
basis. And gravity is one of the biggest ones. And just to put it plainly before I just play a few seconds of these videos, 'cause I do want to cite my sources. Like this isn't none of the information that I give or have is my information. I'm not a physicist. I just
mhm,
read and listen to what the most up to date scientific journals are and what's going on in the colliders. And when that happens, new information comes out. And when it comes out, it very very rarely is in line with the known state of science. And so you
mhm,
know gravity, right, specifically, uh, was debunked over 100 years ago. I'm not sure why people try to pretend like that didn't happen, right? Just by simple observation of looking at the galaxy clusters, right? And then they had to redo the theory of gravity to change it to being the bending of space, the bending of the bending and warping of space time. Excuse me. They had to change it to that because of the observations of 1935. And then again, they had to change it in 1955 because of more astrological observations. And so right now, the whole theory of gravity, so to speak, which, like I said, has actually been debunked, right? But the people who are holding on to it, they're holding on to it they're holding on to it by way of dark matter, right? The bending and warping of space-time. And this video that I have up right here is a physicist in the field who's saying that they have confirmed, well, I won't even use the word confirm. They have basically 5 sigma confidence, which is
mhm,
essentially 99.99%, right? That there is no existence of dark matter. They have not been able to detect it. And as a matter of fact, it doesn't even work in their math projections anymore. So, I wanted
mhm.
to just put like at least play a few seconds of him kind of addressing that. And then I have another video up here of let's see which one. Um, I got to pull the other one up still, but I'll pull the other one up while this one is playing real quick. But this is just him kind of briefly explaining, what I mean, what's going on with our current theory of dark matter.
Okay,
You cling on to.
Let me know if you can hear it. Okay.
I can hear fine.
large imaginary clouds, which is just now racing past our Milky Way, very confidence. The ball would just fall down quickly. So the collaborators I have in many countries,
All right.
negligibly small. You just don't want to entertain that idea anymore because it will absolutely not be economic.
So going back to dark matter, what makes you believe that dark matter's existence has been disproven with such high confidence?
Because we've done, since 25 years, we are studying the properties of galaxies, and we've put a lot of emphasis into understanding how galaxies function. So we means myself and the collaborators I have in many countries. And there are a few key experiments you can do, experiments in the sense of the theory making very clear,
I want to speed it up
hard
just a little bit.
predictions, the dark matter theory, and then we can test that against the observations. And one particularly strong prediction is that if you have galaxies orbiting other galaxies and they are moving around in the dark matter halo, so every galaxy has this huge dark matter halo, and if it's moving around this dark matter halo, it will be suffering, it will be losing kinetic energy, so it will be getting slower and falling towards the center of the other galaxy and merge. So this is called the dynamical friction. So same as if you have a pot of honey and you put a marble into the honey, it will not accelerate downwards, but it will slowly sink. Yeah? Although if you have the same pot without honey, the ball would just fall down quickly. In the honey, it will sink slowly. So that is basically the same thing happens in a dark matter halo. A galaxy enters this dark matter halo.
There's only another minute or another minute.
Accelerate fast as it should if there were no dark matter halo. So we've tested this observationally, and the effect of the slowing down is not there with that type of confidence. And so galaxies are encountering each other far too rapidly. And a case in point is the Large Imaginary Clouds, which is just now racing past our Milky Way, very close to the Milky Way actually, and it's far too fast. So and the Small Imaginary Clouds too.
So this was a prediction that was made by the claim that dark matter exists, and it's been falsified.
Yeah, absolutely.
So why do people still, in your view, cling on to this idea of dark matter?
Well, that's an interesting sociological problem, which one would like to understand because it has no rational basis. It is non-rational, and it's probably related to...
I'm gonna put the subtitles on and play that part back one more time. Listen to his question and listen to the answer.
So why do people still, in your view, cling on to this idea of dark matter?
Well, that's an interesting sociological problem, which one would like to understand because it has no rational basis. It is non-rational, and it's probably related to sociological pressures in the community. So
there you go. So that is him basically saying that we've disproven dark matter again, right? Up to 5 sigma confidence. And he's like, okay, well, why do people still cling on to this? I have no idea. It's non-rational. There's no rational basis for people to still claim. There was no rational basis for people to claim that dark matter was there in the first place. But at this point, I mean, it's been disproven. I mean, through our current mode of operational physics, it absolutely has no rational basis. And I have other videos that really break it down mathematically, but I think that's a bit too involved, to get into right now. But while I'm pulling up the next video, did you want to comment on that? Because I have another video.
When is that from?
From Lex Friedman's podcast talking about something similar. Go ahead.
When is that from?
This is actually an old interview, but
when was the actual interview?
Yeah. So this is the actual interview right here. So you can go look it up. And honestly, what he's
from 5 months ago.
I'm sorry. Go ahead.
It's from 5 months ago.
Yes. Yeah.
Okay.
Yeah. So
what's the next one you want to show?
Okay. So you don't have any direct comments on that one?
No.
All right. All right. So this is.
When you say space-time is doomed,
right. And by the way, these readings that they're talking about are from the Large Hadron Collider and other colliders around the world. You know what I mean? So when they do these experiments, right, they try to fit the fake cosmological model of gravity, which really, like I said, doesn't even work on the cosmological level. They try to fit it on the quote unquote subatomic level, and it doesn't work there either. The only place that quote unquote gravity has any basis is in our downward acceleration, but really they're just measuring the downward acceleration that all particles have being attracted to the incoherent magnetic mass that is the Earth. So really they're just measuring that, and they call that gravity. Even in the equation they put little g, because it really is just a calculation rather than an actual acknowledgement of a force, if that makes sense. Okay, so here's Lex Friedman. Well, this is actually Donald Hoffman talking on Lex Friedman, but he's reporting on the work of 2 physicists from Princeton, and then a Nobel Prize winner David Gross. So he won the Nobel Prize in 2004, and they've been doing this work. And honestly, I like this is a lot of the stuff that I was reading on before I even considered. Before I even watched one flat Earth debate, this is the kind of stuff that I was reading on, because it started to fit in with what it is that I kind of already had preconceived about what the universe in the world really was. So as information about the collider comes out, I'm reading it and I want to see, okay, what is it? Are they discovering about what's going on in our world? And at the end of the day, it always comes down to, man, we thought we knew this, but then we got this data, and now all that data is canceled out. We don't know. Every level they go deeper into the collider, they don't really know what they're looking at. And as they get to a level where they have some grasp on reality, it all kind of pans out to everything being a different modality of one substance. So they're basically like slowly but surely making their way all the way to acknowledging what Tesla already knew, which was that there's an ether, right? Or basically everything is a dielectric background. And at a certain point, when it goes into certain motion, then it creates electricity or light, right? Which gives way to what it is that we experience here in this universe, which is basically condensed light, right? So I'll play this really quick, unless you have a comment.
No comments yet.
Is it the space? Is it the time? Is it the very hard coded?
It's a very long question.
3 dimensions plus
Right.
1 4D.
So Lex Friedman is basically asking them, all right, when you guys are publishing these papers, right, that are saying that space-time is in jeopardy, right? Which, if you're saying it's in jeopardy, that means it's already out, right? Because if you haven't proved something scientifically, it's not a scientific theory. It's at the most a hypothesis, and that's only if you've observed it. But they never observed space-time because those are two abstractions, conceptual abstractions. You know what I mean? Stuff that you can't actually touch or hold. So it's theoretical at the end of the day, which means by definition it can't be scientific, right? But whatever, we've accepted it into the science, to the scientific mainstream. And so I like to watch and see as these things just get debunked one after another. So that's basically what they're writing about right now with the debunking of not even just, like I said, dark matter. So now this is debunking space-time altogether. So gravity is supposed to be the bending and warping of space-time, but that only works, right, if they can insert some fake dark matter in there, right? 83% of all quote-unquote matter is dark matter. 97% of all energy in the universe is quote-unquote dark matter, right? So basically their equations don't work at an 83 to a 97% percentile. So that's already saying it doesn't work. And now right now they're saying like we can't even prove the existence of space of quote-unquote space-time, which, like I said, are by definition conceptual abstractions, you know what I mean, alone. So they already don't exist. But now this is just the proof. Like there's no, like, both sides now agree, right? The side that is on scientific consensus and the side that disagrees, we all have to come together and agree now. Is like, it looks like there is no such thing as space-time. And what we think gravity is really is just an electrostatic relationship that everything, has with one another. All right, I digress.
What do you mean by space-time is doomed?
Great. So this is, by the way, not my quote. This is from, for example, Nima Arkani-Hamed.
There you go.
At the Institute for Advanced Study at Princeton. Ed Witten, also there. David Gross, Nobel Prize winner. So this is not just something the cognitive scientists, this is what the physicists are saying.
Yeah, the physicists are space-time skeptics.
Well, yeah, they're saying that, and I can say exactly why they think it's doomed, but what they're saying is that, because your question was, what aspect of space-time, what are we talking about here? It's both space and time, their union into space-time as in Einstein's theory. That's doomed. Mm-hmm. And they're basically saying that even quantum theory, this is with Nima Arkani-Hamed especially, so Hilbert spaces will not be fundamental either. So that the notion of Hilbert space, which is really critical to quantum field theory, quantum information theory.
Right, so as they do experiments in the collider, Hilbert theory becomes obsolete. It has no bearing on the reality that they're seeing in the particle colliders, right? So he's saying like we are coming up with new theories of physics that are basically superseding all of these and rendering the rest of these theories useless. So like as you get rid of Hilbert theory, if I'm not mistaken, yeah, if I'm not mistaken, Hilbert theory is a key fundamental of quantum theory altogether. So once Hilbert theory goes, then there is no quantum theory. So it's like now we're back at nothing. Nobody knows anything anymore.
That's not going to figure in the fundamental new laws of physics. So what they're looking for is some new mathematical structures beyond space-time, beyond Einstein's four-dimensional space-time or supersymmetric version, geometric algebra signature 2,4 kind of. There are different ways that you can represent it, but they're finding new structures. And then, by the way, they're succeeding now. They found something called the amplituhedron. Right. This is Nima and his colleagues. The cosmological polytope. There are these like polytopes, these polyhedra in multi dimensions, generalizations of simplices that are coding for example, the scattering amplitudes of processes in the Large Hadron Collider and other colliders. So they're finding that if they let go of space-time completely, they're finding new ways of computing these scattering amplitudes that turn literally billions of terms into one term.
All right, so that's one of the most important things ever been said on the internet, period. right? So when I say something like everything, all matter is just condensed light, right? Or condensed electricity, whatever word you want to use for it, right? And they say, no, it's not. It's quarks and neutrons and all these different things. Okay, great. So these are all theories, right? Until they do experiments in the Large Hadron Collider, and they're trying to fit what they're seeing into the mathematical model, right? That has all these different variables in it. And they're saying, like, look, what we do to make it simpler is we basically take all of these variables and we find a way to condense them into the same variable that's acting in different ways. I try to make everything as simple as possible so the average person can understand it. They like a quark and all these different things that they think exist. It's easier on their math and based upon what they see in the reality if they assume that all these things are basically just one thing. If they assume, okay, these aren't different things, these are one thing acting in different ways, it makes their math more simple. So that falls closer in line with my theory that everything is dielectricity in just different forms of it. You know what I mean? And that's a deeper version of it, right? But the on the surface, right? It's complete. They're saying, he's saying that if we completely remove space and time as a factor, right, then it makes more sense what we're seeing in the quote unquote coding, right, of what is happening when these particles smash together, right? If we try to add fake space-time to it, then it literally doesn't make sense and we have no idea what's going on.
When you do it in space and time, because it's the wrong framework, it's just a user interface. That's not from the evolutionary point of view. It's just user interface.
Right. So just to make it as simple, he's saying like space-time is our particular user interface, and it's just an evolutionary user interface, if that makes sense, right? Evolutionarily or adaptatively, right? Adaptatively, we have learned to view the world in the realm of space-time the way we do it now. But that's the user interface. Like if we're looking at a computer, right? Like, you know, we know the first computers didn't even have interfaces on it, right? So the first computer, you had to do some work and then print out to see what it is that you were doing. So this interface that I'm looking at right here on my computer, that's not what's actually going on under the hood. This is just an interface that makes it easiest for me to relate to the environment that I'm around and control the information intake from what's useful and not useful, right? So that's what space-time really is. So he's saying that when we look at the collider, we have to basically remove all that and understand that that's basically just a construct, right? Space and time together is just a construct of our own mind. So once we remove that, then what we're seeing in the collider actually makes sense, you know, if that makes sense.
Right? It's not a deep insight into the nature of reality. So it's missing deep symmetry. It's just user interface. It's not a deep insight into the nature of reality. So it's missing deep symmetry, something called a dual conformal symmetry, which turns out to be true of the scattering data, but you can't see it in space-time. And is making the computations way too complicated because you're trying to compute all the loops and Feynman diagrams and all the Feynman integrals. So see, the Feynman approach to the scattering amplitudes is trying to enforce two critical properties of space-time, locality and unitarity. And so when you enforce those, you get all these loops.
Oh man, this is such a deep subject, but it just, there's so much here. All right. So basically what he's saying, like, to think about it, locality and unitarity, right? These are the two concepts basically that are holding us back when it comes to space-time, right? Like locality, are atoms individual or are they one connected chain of things, right? Once we remove the idea of locality, like is the atom here or there? Once we stop doing that, he's saying then it opens up the whole spectrum and things start to make sense. Once we try to pinpoint things based on locality and unitarity, then it turns one variable into a billion variables, and even the top supercomputers on the planet cannot compute that. I hope that makes sense.
And multiple, different levels of loops, and for each of those you have to add new terms to your computation. But when you do it outside of space-time, you don't have the notion of unitarity. You don't have the notion of locality. You have something deeper, right? And it's capturing some symmetries that are actually true of the data. But then when you look at the geometry of the facets of these polytopes, then certain of them will code for unitarity and locality. So
I'm gonna stop it right there because there's just so much in this video. All right, but that last thing that he's saying, right? Like I said, I mean, the computer coding example was perfect, right? It's like when you're coding, right? The computer code doesn't look anything like what the website looks like. So we look at the website and we're examining the website, trying to figure out what's going on just in the parameters of the interface of the website. So he's saying in the collider, this is not literally what he said. I'm trying to dumb this down so the average person can understand it, right? So basically what he's saying is when we look at the collider and how particles interact with each other, right? We're looking for patterns, right, that repeat, that allow us to like we're looking for the ones and the zeros, right? Like we're the ones and the zeros, right? So like breaking it all the way down to what is the pattern behind it that is giving way to the interface that we're seeing. And so that's basically what he's saying, is that when we do that, right, the actual structure that they're calling it is the amplitahedron, right? But again, that's just another made up name, right? For, they can't say it's a shape anymore. It's basically like a movement, right? So that's why when they say stuff like light is a particle and a wave, right? Like people in modern science, they say stuff like that. Like light is a particle and a wave, right? So light can't be a wave. Nothing can be a wave unless you're describing what it's doing to something else, which is exactly basically what he's saying here. He's saying that when we look at things like locality, right? Locality can actually be represented in basically like the coding of the amplitahedrons. So instead of looking at things as the thing is here, right? We're looking at it as when it does this movement, it's there. When it does this movement, it appears to be here, right? Like light, for example, right? People like to say light is a particle. Light isn't a particle. Light is something that quote unquote particles do, right? So when they say light is a wave, right? So it is a wave, but what is waving? Right? What is waving that gives light, right? Light's not a particle. It's what something looks like when it does a certain motion. All right. So I'm trying to say it in the simplest way, in the simplest way possible. But essentially, that's what they're discovering, right? But like I said, like this is like light years past whether or not gravity exists. Like they're like, not only does like gravity not exist, the particles like atoms don't exist. You understand? There are different modalities, right, or different movements of what they're calling amplitahedrons. But an amplitahedron is just a shape. Something can't be. I hope this makes sense. Like if you're saying that something is a square, right? Okay, but a square isn't actually a thing. It's just a shape that a thing makes. So it has to be a shape of something. They don't want to admit that it's just dielectricity because, like I said in my debate, that comes with free energy. That's what this leads to. Once you admit that everything is energy, everything is electricity, now we don't have to pay for it anymore. We can access it for free from the ether, the air, the medium, whatever it is that you want to call it. You know what I mean? So like I said, I have so many more examples of professors talking about how what we see in the large in the colliders, right? Not only do they support that there's no gravity, like I said, because that's been done 100 years already, but they support the idea that everything is one all life-giving substance, right? Like in the beginning, in the first part of the first video that I showed, the part that I skipped, he said that in the same way that he's not confident about dark matter, in the same way he's confident about dark matter not being there, that's how confident he is in the existence of the Higgs boson, right? Or the God particle, right? Which to me is just another way of saying ether. They're like, there's a particle there that holds electricity, and when we need it, it brings electricity into the universe. That's the same thing that Tesla described when he was talking about the ether, So that's my quick little spiel on I mean, why gravity is a cooked turkey. You know what I mean? It's I can't believe anybody actually even still brings that up in debates anymore, because like I said, they stopped making it about mass in 1930. So since 1930 all the way past 1950 to now, it's been the bending and warping of space-time, right? Based upon the existence of dark matter. Dark matter has already been debunked. And like I said, dark matter was never anything real. And then space-time in general has been debunked. So there is no gravity, there is no space-time, there is no bending and the warping of space-time. You know what I mean? Intellectually, if we really want to find out what's going on, we gotta let that die, and then move on to parsing through all the information that's coming out of the colliders and out of the research institutes, because they're publishing papers every day, and I'm reading them motherfuckers. Trust me. And like I said, even before I started watching the flat Earth debates, I already was on the side of quote unquote true Earth. I already understood that what we think the Earth is not what it is. That there's something, there's something a lot more fluid going on in our quote unquote solid universe. You know what I mean? It's not nowhere near as solid as we think it is. And there's a direct connection between what we perceive to be solid and our direct consciousness. You know what I mean? Like I said, there's experiment after experiment that have been done to prove this. But I have another one that deals with gravity and specifically what's going on specifically what the Earth is and what the force that we think gravity is. But you're more than welcome to jump in at any time, though, man. Like, you know.
I'll watch the last video, then I'll ask some questions.
Okay. This is not even the right video. This is not the right one, but this is an example, though, right? Of what we're talking about. This is what gravity is essentially right here. You know what I mean? So different magnetic fields, which, like I said, everything is energy, frequency, electricity, magnetism, all the same thing. It's like different modalities of water, right? H2O, ice, you know what I mean? All these things are water, but they're different modalities. So electricity, magnetism, it's all the same thing. So when you have two coherent fields, you know what I mean? Well, I don't want to get too all right. So coherent and non-coherent fields have a reaction on each other, right? They either push or pull, right? So the thing about an incoherent field is that the bigger the incoherent field, the weaker the attraction gets, right? So Earth is one large coherent field. So we have a very, very weak attraction to the Earth, but there is an attraction there, which gives us our downward bias, right? So and there's also an electric charge pushing down on the Earth that's measurable, right? 100 volts per meter as you go up, measurable, right? Measurable and like I said, you can run a C word generator, right, off harnessing the electromagnetism in the atmosphere and converting it into energy. So this is how you can use magnetism. Like essentially what we're watching here is we're watching energy being pulled from the ether. Like I said, without you know what I mean? Like nobody really understands what's going on. But they theorize all day. There was one person that felt like he understood what was going on. His name was Nikola Tesla. By the way, he invented everything we use today. So, you know, well, we haven't had any discoveries that go against that. Like I said, those two videos that I showed of the two scientists talking about what they were discovering in the colliders, that's them basically saying like, oh, wow, all the stuff that we came up with that basically tried to debunk Tesla, it was all wrong, and we're having to go back to what Tesla knew from the very beginning. So, like I said, this is the wrong video. There's another video that really shows exactly how different magnetic fields move on the Earth and how we react to the Earth. Anyways, it's really neither here nor there. Like I said, I personally feel like gravity is a cooked turkey. But, you know, I always like to spin it into something that is useful and valuable for the average person. You know what I mean? Because, you know, like my favorite thing to say is science is irrelevant if it doesn't improve the life of the average person. You know, you could be the greatest scientist ever, have the greatest inventions ever, but if you do it all in a cave and nobody gets to use it, then it means nothing. It really didn't even happen, you know. So that's my spiel, man. I'm ready for your questions now.
Okay. And I heard you say that you read the papers. I remember you mentioned that in the debate that you had with Leo Philus, and you showed like 7
Yes.
papers on the screen.
Yes.
I wasn't clear on. Did you read all 7 of those papers?
No, definitely not.
You didn't. How many of them did you read?
I mean, well, I read the prompt and the actual page that I could access without paying for it. I read everything that I could read without paying for it. But these are I don't want to say old papers, but here, I'll pull them back up for you because I have them right here.
Okay.
Let's see, 1 second. Right. So these papers are basically reporting data. And like I said, like this is all stuff that I literally knew and was in the hill that I was dying on before I had ever heard of flat Earth. So I didn't read these papers, no, but these papers are the things that I personally was trying to convince all of my friends and family of. about what was really going on with the world before I even accepted flat Earth as an interesting subject. So they're talking about, like I said, these are old experiments that have been done at infinitum, right? So quote unquote gravity, right? Quote unquote gravity. Like I said, you can do this through experimentation, Van de Graaff generators. During my debate, I showed how sound levitates thing. That's us changing the gravitational nature of the object and thus affecting thus changing the effect that we see as quote unquote gravity. So that also happens during thunderstorms, right? And not only just thunderstorms, but it affects electromagnetic frequencies at the same time, right? So when there's a thunderstorm, obviously the our magnetic fields are being disrupted, right? So you can actually measure that, and then you can measure the rate at which things fall based on during a thunderstorm and outside of a thunderstorm, and there's clearly a connection between the two. So that shows that there is
You're
an
saying that's what this paper here is saying?
Oh well, this and this one right here, and pretty much all of these paper are all based upon that principle, because that's like I said, it's such a it's a principle that's been like beaten to the ground so much. That's why I really didn't even need to read these, because this is kind of stuff that I already knew. But it's just the backup that I brought just in case, because I know most of the people who watch that channel, they worship paper. It's like, if it doesn't say it in the paper, then I don't believe it. All right, well, science actually isn't really about paper. It's about observations and experiments. And yes, you show the observations on paper. Yes, you show the experiments on paper, but the paper themselves is not the evidence. You know what I mean? If you still want to know for sure, then you would still have to go do the observations and the experiments yourself. So I just like they're all on pretty much the same thing. The electromagnetic nature of gravity, right?
And what you're saying is that gravity changes in a thunderstorm.
Well, what we perceive to be gravity, which is basically the rate at which things fall, right? The rate at which things fall changes during thunderstorms. Yes, ad infinitum. Yeah.
One moment here.
Go ahead, no problem.
Right. So this paper is actually pretty short. How am I able to share
I previously
the screen?
demonstrated.
Go ahead.
Can I share the screen on this thing, or can I share
Oh,
something?
yeah. I believe so.
Oh, I see. I just hit present there. Okay, hold up. Let me try to get this worked out so I can share this here.
Go ahead.
And it might be better if I just actually download it. Let's open it up. Open up the actual PDF. All right, there we go. Right. So present. Share screen. They're gonna let me pick what screen, or there we go. It's working.
It is.
Okay. So let me know if you're able to see the paper now.
Yes.
Right. Let me zoom this thing in.
Here we go.
So during the past 3 decades, a number of investigators reported extreme evidence we've seen this heavy rates disturbances, and in particular sporadic losses. Reporting. All right, so it's saying ionospheric disturbances, and let me know if you catch the part where it says gravity changes. And this is the first one you pulled up from Nature, the mechanism for the generation of acoustic gravity waves during thunderstorm formation.
You want to see if they actually say in here that gravity changes?
I'm trying to see if this, because you said this. I'm trying to see if it matches what you're saying or supporting.
Okay.
Right. And let me know if you see it before I do.
Well. Okay. So I'm go to the top real quick, right? So
Okay.
just for example, right, the driving force for the updraft would seem to be an instability of the lower atmosphere, right? So even something as simple as that is them admitting that there are other variables besides the weight, right, that affects the rate at which things fall. You know what I mean? And not even just other variables, they're saying the driving force seems to be a disturbance, right? So there's a disturbance in the lower atmosphere that is affecting it, right? So it doesn't
So what
necessarily
exactly
mean,
does updraft mean?
huh?
What exactly is the updraft?
The driving force for the updraft. I mean,
What exactly does updraft mean?
I mean, just in context, I'm assuming they're talking about the variable recordings of the data.
Updraft means the variables of the recording of the data.
I'm saying in context. I'm just like, yeah, reading it in context.
But what's the rest of the context?
I mean, you want to read the whole paper right now? I mean, we can. You feel me? But you know, it's
Well, that's what I was starting to do, but you stopped me at a sentence and started explaining as if
well,
you
yeah. Well, I
understood
mean,
it. That's,
okay. I mean, I mean, if you want to read the whole paper, go ahead. You feel me? But
I mean, it's only like 2 pages, so it shouldn't be long to scroll through. I mean, I don't necessarily think we need to read the whole thing in detail, but the whole thing is just literally actually, it's not even 2 pages. It's like a page and a half. Like the bottom of it is actually a different article. So the article itself is a page and a half. So we can scroll through this one here and see if it supports what you see. Because at the moment, the updraft explanation, it being some kind of grouping of data, doesn't support the idea that gravity is changing, to my understanding. So we'll go through it here. During the past 3 decades, a number of investigations have reported experimental evidence which are seen to indicate that thunderstorm activity may be related to ionospheric disturbances, and in particular, to sporadic E. So what is the E? What does the E here stand for when it says sporadic E?
I'm sorry, bro. Say that again.
It says, during the past 3 decades, a number of investigators have reported experimental evidence which was seen to indicate that thunderstorm activity may be related to ionospheric disturbances and, in particular, to sporadic E. What does this E stand for here?
Yeah, I'm assuming that it's the beginning of this guy's name. Yeah, I don't
Do
reading
you
it.
think E is the beginning of someone's name?
Yeah, I'm assuming it's really. It says
Oh,
too sporadic. E. Roberts et al. Have provided more recent evidence in their data of path losses of 21.6 MC per second radio waves transmitted from Panama and received at Stockbridge. So
right.
this is them. This is actually the pool of the gravitational waves on.
Well, we're just talking about just the E right
This
now. So you're saying the E is the first part of this guy's name. So you're saying in particular, who sporadic E. Roberts et al. Have provided more recent evidence. That's what you're saying. You're saying.
Yeah, at first glance, right
Okay.
here, that's what I'm going with.
Okay. That's provided more recent evidence in their data of pad losses of 21.6. And what is this units right here?
My bad, bro. I'm trying to read and listen to you at the same time, bro. Ask me again, bro. My bad. I'm trying to.
Perhaps we
I
could just
can't
keep
do two
together and
things at
go
once.
through it.
I'm reading
So
and
it says, so according to your reading, in particular to sporadic E. Roberts et al. Have provided more recent evidence. I'm right here in their
you're asking about
data of pad losses of 21.6 MC/S. So what I'm asking is, what is this MC/S right here?
that. That's megacycles per second.
What does that stand for or mean?
Yeah, I believe it's megacycles. Yeah, because megahertz is mh. So I think it's megacycles.
What would that be, or what would that relate to?
Okay. All right. So if like I said, if we're saying that light is away, because this is them sending basically light frequencies from one path to another, right? I don't think this one is specifically about the gravity of objects. I think it's about how how basically lightning is affecting the cycles per second of the light beams that they're sending from one point to another. So they're showing
So you're
how
saying this is not saying gravity is changing anymore.
they're saying that the gravitational effect that is present on all light beams, right? Because there's a gravitational downward bias on all things, and you can test it through laser interferometry, right? So if you have a
Let's keep going.
laser,
Perhaps we just
if you
That's
have a
fine. Perhaps we
laser,
just didn't get there yet. Like I said, there's only a page and a half. We just didn't get there yet. Let's see what we got.
Well,
the
I'm
21.
basing that off what I've read in this first section, because they're talking about sending
Okay.
laser. They're talking about sending beams from one place to another, essentially, right? And the cycles per second, right? The frequency of the laser is being affected during a thunderstorm, right? And that is akin to gravitational pull, because if I shoot that laser, right, that's how they basically know that there's a quote unquote effect of gravity. You can have like, if like I said, if I'm shooting a laser, right, you will see a very, very tiny downward bias that's affecting the frequency, I mean, the cycles per minute or whatever it is that you want to place as a meter of measurement on it. And they're saying that it's affected during thunderstorms, right?
So I need you to point out, where exactly did you get that understanding from what we read so far? Like, what words is it that let you know that all you said just now is
right.
what they're
Radio
saying?
waves transmitted from Panama and received at Stockbridge, New York. They reported a new
Let's see
time
that. But I'm
disturbance.
saying, from
I'm
that,
telling you
what
what
do
I
you
read.
think gravity pulling
This what,
down and
well, what's it, like I said, when you asked me if I had read all these articles, I'm like, no, I didn't read all the articles, because this is something that I've been knowing for years, right? That everything is
which one of these have you read that you pulled up?
I didn't read any of the articles. Yeah,
Okay.
I didn't.
So
Yeah, I didn't.
let's finish this one in.
Yeah,
So
and
we
I'm
know
telling you,
that's
this is what
transmitting
I was
radio
reading right
waves,
here. Radio waves
right?
transmitted from Panama received at Stockbridge. They reported a new time disturbance, right? The new time disturbance represented a marked decrease in adoption below normal levels. Onset trend had occurred between, you know what I mean? And honestly, bro, I would encourage you, if you really, really want to know the truth, right? I would encourage you to take this and read it in your own time. You know what I mean? Like, like literally, like
Well, what I'm doing is, you said this paper says a certain thing, and you express having an understanding of gravity and an understanding of what this paper says
what
from
did I
reading
say
the page.
specifically? What did I say specifically?
You don't remember what you said? I
I
mean,
remember what I
we
said
were
specifically.
talking.
I want to know if you
Okay,
know what
then
I
then
said.
let's read the paper and see if it says that. All right. So,
Yeah.
onset tended to occur between 11:15 and 12:15 Eastern Time. The disturbance duration was about 1 hour. We find this evidence particularly suggestive as the pad passed over a portion of Florida, especially noted for intensive thunderstorm activity. One of our colleagues, W.J. Brentley, has checked on thunderstorm activity. August 19, which one of the 2 dates supposedly cited by Robert et al., for which new time disturbance was observed, and found that a thunderstorm did exist in the region near the propagating pad. Furthermore, the fact that thunderstorms tend to occur in the summer months and in the early months would seem to corroborate reported times in the noontime disturbance. This evidence is highly circumstantial. It's also pre-verification. It does tend to reinforce the belief that far duration devoted to possible with thunderstorms can exert an influence on the ionosphere, and that additional experiments should be carried out that will provide more conclusive evidence. I don't see it yet. Did you see the part yet, or should we just keep going?
I'm
It's
not gonna
talking
lie to
so
you,
far about effects on the ionosphere of thunderstorms. In
brother.
this article, research suggests a mechanism by which energy can be propagated from a thunderstorm during its early stages to the ionosphere, by which an ionospheric disturbance can be created. The mechanism involves the generation of acoustic gravity waves by air movements in a thunderstorm and the propagation of these waves to ionospheric levels. We're talking about a mechanism that will generate acoustic waves by air movement in a thunderstorm. Okay? The belief that acoustic gravity waves propagating upward from the troposphere may be responsible for a number of types of ionospheric disturbances has become increasingly widespread in recent years. Science has showed that many of the most observational data pertaining to irregularities and irregular motions in the atmosphere may be interpreted on the basis of, okay, so it's saying Hines has shown that many or most of the observational data pertaining to irregularities and irregular motions in the upper atmosphere can be interpreted on the basis of atmospheric gravity waves, that is acoustic gravity waves. So it's telling you that there's atmospheric. The atmosphere is not moving necessarily how we would anticipate, except for gravity waves being created in the atmosphere.
Quote
And that's
unquote
why
gravity wave. They're just using the word gravity waves. It's the same thing, like I said, it's saying electromagnetic frequencies, mechanical waves. That's what they say. Radio waves, whatever word they want to put to it, they're calling it gravity waves. But like I said, it's electromagnetic frequencies that are affecting the rate at which things move and are attracted to each other electrostatically. So
So where are you getting from this that they're saying is electromagnetic waves?
when they say
Like, where are they
gravitational
saying
waves,
that?
when they say gravitational waves, that's essentially what they mean, because they're making that up. Everything in this paper is made up. The conclusion of this paper and all the other papers, right, is that at the end of the day, we don't fucking know. We don't know. We think it's this, that, and the third. But then when we look at thunderstorms, there's an effect on our other magnetic fields that we can't explain. You know what I mean? And the only thing
Right.
that makes sense is that
Okay. Well, we'll get to the end and we'll see if they conclude that they
we're
don't
gonna have
know
to do
anything.
it. We're gonna have to do it quick though, man. You know what I mean? Like I said, I'm
Okay.
like, that's what I'm like. Yeah, I don't know how much
It's only like
how much time you got left. You feel me? But we gonna, you know what I
no
mean?
no problem. They believe that acoustic, and I lost track of where I was. Hold up here. Okay, here,
Right.
irregularity. Okay, okay, cool, whatever. And that's a discuss about these waves in the troposphere. What has investigated the propagation of these waves from the troposphere and has found that a window can exist for wave periods between 10 minutes to 2 hours, which fairly large amounts of energy can sometimes flow out of the troposphere. Although Goss had discussed several mechanisms by which such waves can be generated, he did not suggest any mechanism by which a thunderstorm could generate acoustic waves. Shepard also suggested mechanisms to review certain known features of thunderstorm formation. The thunderstorm cell stage the upward and updraft extends throughout most of the cell. And these updrafts are generally in the order of 10 seconds, but may locally particular times exceed 100 feet per second. The driving force of updraft was seen to be an instability in the atmosphere. So it seems that you were incorrect about what an updraft is. It looks like they're literally talking about
It's very
movements of
possible.
air upward. Huh?
That's very possible. I pulled the definition out of my ass.
Okay. So if this instability occurs in a region near the ground where locally the potential temperature decreases with height, then air in the lower layer rises, causes the updraft. Talking about air moving upward at what it says between 10 feet per second up to exceeding 100 feet per second. The level is reached where the potential temperature, which is not change in abiotic expansion, is equal to that of the ambient air at the same altitude. The cooling of the air as it rises may cause a condition of water vapor, and this condensation gives up energy, to which the air in turn tends to increase the potential temperature and cause the driving force of the updraft to be more intense. Equilibrium height and unstable air increases the effective temperature in the state match increase of height. As unstable air rises in height, and it overshoot this and you pull it back, the net result is oscillation in air, but at altitude approximately the same height as the cloud tops. The period of oscillation should be about the same as that of the local period. That is, in particular for vertical oscillation observed by the example of the curve of vertical velocity to its cloud top vertically derived from measurements of photograph. Example shows that.
Bear with us, everybody, as Daryl gets up to speed. Bear with us. Bear with us.
Anderson measurements are particularly suggested here at correct water back to the broad period, which sure. The total energy taking into account the magnitude and per unit volume. I still haven't seen where it said what I heard you say they said, but so right now they're talking about basically the giving and exchange of energy.
Let me ask you this real quick though. What are we hoping to get at the end of this? What are we heading toward? Just so we can.
I was very honest and clear up front. I wanted to see the article to see if it's saying what you're saying is saying.
But I respect that, but you're gonna have to do that on your own time. Like we're not gonna sit here and just listen to you read. You know, that's not very interesting. You know what I mean? If you're not sure,
do you agree then that this article does not say what you said it said?
No, I don't. But if you're
then we should continue to see
well,
if it is.
I don't want to sit. I don't sit here and listen to other people read. Like that's not interesting, right?
We only have what?
Even though we are trying to get to the bottom of it, we also want to make it interesting for the people who are watching, right? So let's not like if you're not sure about what I'm saying, let's move on from that, right, to something that maybe you are sure about, so that way we can maybe make some ground. Because you're reading this for the first time, that doesn't mean you're going to understand it on the first time, right? Let's just, you know what I mean? Like I said, I literally
let's think about this for a
articles.
second. Let's think about this for a second. You just said I'm reading it for the first time. That doesn't mean I'm going to extend it for the first time.
Yes.
You haven't read it at all, and you're making proclamations.
Yeah. No,
so how do you think that
it's
relates?
basically me. It's basically me, and I'm admitting this. It's me cherry picking articles, right, from scientific journals that fit what it is that I already know through experimentation. Notice I didn't bring those up as evidence, right? I never brought a single paper up as evidence. You wanted me to bring it up because I get it. You're part of the paper worshiping scientific, you know what I mean, cult or whatever, right? You guys love paper. So I brought it up for you guys, but it's still not evidence. It's just a piece of paper. Anybody can say anything on a piece of paper. That doesn't mean anything.
It's just a piece of paper. Okay, sounds good. So why don't we do
that's
this?
Why I brought up the videos and examples of people actually in the field doing the actual work, talking about what they're actually viewing in real life. Paper's not real life. Paper's just paper. It might as well be the Bible. You know what I mean?
All right, sounds good. So another thing you had mentioned, you were saying that science is irrelevant if it doesn't improve life of the normal person.
Absolutely.
All right.
Yes.
And so I wanted to ask you a question that because I remember you had mentioned Witsit. I remember DFC a while ago asked Witsit this question. He sort of ran away from it. If you have a ball that's dropped from 10 meters on the ledge, what is the object's exit velocity before it hits the ground? And show us how you calculate that with uh, what you were saying about the generation of electricity and uh, magnetic fields, and how do you calculate that? Like show us the way that's calculated and the formulas that you derive and how that's done to get the velocity of that thing when it gets down.
Okay, well, I'm gonna see if I have a photo in here that actually does break this down mathematically.
No, 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 no.
But
I'm not
because
asking a photo. I'm asking for you to actually
I'm
utilize
not a
this.
mathematician. I'm not a mathematician, so I don't know why you're asking me that. I don't know. But I can refer you to the mathematicians that I look at when they describe this, right? That's what I do. Especially if I'm completely lost, right? I'm going to assume that the people that get respect in their field, right, at least know what they're talking about when it comes to math. And so what I do is I look at people on both sides of the issues, right? People that agree with me and people that disagree. And then I cross-reference between the two. That's how I research and figure out what's going on. You take people that
Okay,
agree with you,
I'll
people
take
that
a look
don't
and see
agree.
what you have.
I'm going to see if it's in here because it might not be. Like I had that debate last week, and I have like literally 1,000 things. Okay, here we go. Yep, I got it right here. I mean, this is like I said, you have to be a mathematician to really understand this, but this is straight from them. Hold up. Give me a quick second. I got to email this photo to my. As a matter of fact, I'm gonna send it to you on Instagram right now.
Okay.
That's the
Yeah, I should
quickest
be
way I
able
can
to.
get it to you. Yeah.
That's fine. Should be able to get it in. I'll share it.
Yeah. Because it'll take me a minute to send it to my
Okay.
email, and I got a lot going on my computer right now.
Fine.
All right, so I sent you a photo. That's basically taking the a kinetic equation, right? That basically is an an electrostatic kinetic equation, essentially, right? And
And I
basically
apologize.
showing how,
Give my moment. Let me pull it up so I can see what you're talking about. Hold up. I'm still
yeah,
working through it,
no
and I
problem.
could download it to show
Yeah, go ahead, pull it
the
up.
people as well. So they know what you're talking about as well. One moment here.
Right. When they do mathematical equations and they have to insert, little g gravity in there, they show how you can use a kinetic equation, insert it, and it works way better. And this is just math, right? This doesn't say anything about what we're actually observing in the atmosphere. It's just the math. Right.
Looks like this
Hey,
is
I know it. That's what
looks like
Mr.
it.
Jones. That's what he wants to talk about. You feel me? He wants to know about the velocity of drop balls. It's literally just an observation from what we see. You know what I mean?
Looks like it's not
It didn't go through.
window entire screen. Okay, there we go. I can show the entire screen. All right, here we go.
So yeah, if anybody is a mathematician, right, and they want to look at this math and check it out, check the math out. You know what I mean? And
Okay,
see
so
if
what are you saying this is doing again? Now everybody can see it now.
it's essentially showing you how you could take a regular kinetic equation that describes how an equation that works with electromagnetism, how things would react to each other if the fields are coherent. You take that and you insert it for gravity, quote unquote gravity, right? And it works just as good. And in some instances, it works way better because you need a lot less variables. So this is according to the mathematicians, right? I haven't checked the math out myself before you asked me, no. But I look at people on both sides of the issues, and this comes from people who do not agree that the Earth is not moving. They think that the Earth is moving still. But they have to at least admit this. They have to at least admit that there really is no working functionality of gravity, not mathematically, especially if you can insert it for a simple kinetic equation or a
I'm not clear
kinematic
what
equation.
you're
Excuse me.
saying. You saying this bottom equation here, they inserted this for gravity. I'm still not clear about what you're saying. I apologize. You
Yeah,
saying
I'm
they're
just gonna make it.
measuring the same
Look,
thing?
I'm gonna say, look, Jesse Lee Peterson is in the audience right now, and he's black and slow. You feel me? So I want to make sure that anybody can get it. They take the only place that gravity is useful, right?
Mm-hmm.
I'm talking about the actual idea of the force of gravity, not just the rate at which things fall. We're not talking about the rate at which things fall now, because that's just the rate at which things fall. But the force of gravity, right? The only place that is useful is in mathematical equations when we're trying to describe the universe. Because we're like, when we don't understand this, we can insert this equation which describes the rate at which things fall. We think it works everywhere in the universe, and it really doesn't. So when they replace it with the kinematic equation, it works better, according to the mathematicians. So, anybody can go research that on their own time. And if I'm wrong, come correct me on that.
All right. So I'm understanding properly from what you're saying. This is showing that the electricity, like the force of the electromagnetic force, works better than the force of gravity.
Yes, because they're both weak forces, but the electrostatic force would allegedly be like, I don't know what number that is. What is that, like 2 to the? It's like 2 to the. It's like almost 2 to the 40th power stronger. The electromagnetic magnetic reaction that things have on each other based upon how coherent or non-coherent their fields are. Right. So it, not like I said, not only does it work as good as gravity, but in some instances it gets rid of all the problems that we had with gravity because it's much stronger.
So this weight right here, what are these weights talking about? What are
I'll tell
these?
you, I'm not a
What would you
mathematician,
say?
brother. I'm not a mathematician.
I'm not asking you a mathematical question. I'm
Well,
asking
yeah, I mean, you're
this.
asking me specific details about what the variables are pointing to. Is I haven't worked these equations out
You
by
don't know.
myself. I'm just telling you that if somebody is interested, if somebody does want to know this for sure, this is where they can go look and they can investigate further. You know what I mean? I'm not so dragged down on that because, like I said, this fits into what my worldview was already. Right? My worldview was already that what they think they know about science is not true, and everything really is just energy and frequency reacting with one another, different modalities of energy. I somebody told me that. I'm not gonna say who told me that. You think, but somebody on good authority said, "Hey, this is what's going on in the world," and they said, "Watch, science is gonna catch up eventually." So this is just me, like in a way, I'm just cherry picking the things that they're saying that this fits into what I already believe. Well, I'm gonna choose to cherry pick that piece of information, right? At the end of the day,
You
this
get
is
that
math.
from this
It's
image
not
right here.
evidence. Yeah, math isn't evidence.
But you get that from this image right here. All the conclusions you put forth just a moment ago.
You saying where did I get it from?
I mean, this image is what informs you of that. The things that
No, no,
you
no, no, no,
recently
no, no,
said.
no, 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 no. Like I said, this is just me patting my stats. I'm finding other information that agrees with my own personal worldview, right? So it's just math. Like math is not really real. It's just like numbers, right? So they're using math to describe what they see, and when they come up with an equation that describes more what I think we're seeing, then I'm gonna say, oh, look. You know what I mean? Just like just biasly believing in it, right? I'm admitting like it's just blind faith belief because this is just math. At the end of the day, math is not science.
All right, I hear you, man. So let me stroll through and see if there's anything else that sticks out from uh now to make sure I'm understanding properly. Earlier you said that you're unable to calculate the fall of that thing that I discussed earlier.
The what?
I understand that you can't do it. You said that science is irrelevant if it doesn't improve life of the normal person. So
Yes,
what technology is in existence now that's based upon the understanding that you've put forth?
great
Any
question.
understanding, whether it's
Great question.
gravity, quantum mechanics,
Yeah, great question. All of it. Yeah, good. I mean,
all of it.
yeah. Good question. The answer is all of it, right? Because pretty much, and I made this point in an exaggerated way during the debate because I wanted to be provocative, right? I said, what
Mhm.
technology or new invention that we have today that is not pretty much 100% powered by, I guess, a combination of light and sound, right? But let's just take it to straight energy and electricity, right? Everything we use today is electricity based. The person who is the father, right, of all modern electrical inventions is Nikola Tesla. Nikola Tesla literally said word for word that he had to assume there was an ether. He had to assume there is an ether in order for him to bring forth light in the way that we have it now, and basically create his theory of how to send sound frequencies, because he said like there has to be something that's carrying the sound. There has to be something that's carrying the light. So he assumed that there's a background medium, right? Background medium, which he called ether, which is like basically dielectricity. So it's static electricity, and then it goes from static to electrical charge, and that's the world that we live in, right? So it's like like it's the paper, right, to our drawings, right? Like imagine if we're all drawings on a piece of paper, right? He's like, there has to be a piece of paper there, right? Because if I'm like, think about it, like if I'm drawing, right, and I'm drawing a line from you to me on the paper, there has to be something in between there for that line to exist on. I'm trying to make it as simple as possible. That's what he's saying. The ether is like the paper, right? So there has to be, because everything we use today is electricity, right? So where does the electricity come from? There has to be the opposite of it, dielectricity, which is laden or at rest, in a pure potential state, which he called the ether. And he assumed that was there. And from that assumption, he gave us everything we have today. So to answer your question, what do we have today? What technology we have today that depends on what I'm saying? It's everything, right? And Tesla thought everything that Einstein said was completely ludicrous. He thought Einstein was out of his mind because Einstein was not a scientist. Einstein was not a scientist. He did not do experiments before he started coming up with these theories. He worked at a patent office, and he was trying to basically rewrite science. So, yeah.
Well, let me ask you this:
Yes.
our construction technology, like skyscrapers,
Yes.
what is the true way then that they construct skyscrapers? What's the true
You asking
thing
me
that stops them
architecture?
from collapsing? Huh? Yes.
Engineering and geometry, math. Yeah, like
What I'm asking is, what is the real? Because obviously, from what you're saying, the way they say they build these things can't be true if it's all based upon this magnetism and electricity thing. So, what's the actual way these things are constructed, and
Well,
how do you know
I don't
that?
understand your question, because that sounds like a false dichotomy. It sounds like you're saying that I'm saying that if the way they describe the things we're looking at is incorrect, then that means that the things that we're looking at don't exist. I'm not saying that. I'm saying the things that we see and that we know we can confirm are all there. But I'm saying when we go to the deeper level, the things we can't see, the things that we're assuming, things like gravity, right? Because we can't actually see gravity. We know there's a rate at which things fall, but we don't know if gravity, right, is acting
I think.
on
Hold on.
bodies. Go ahead.
But I think. So let me just back up.
Yeah.
To make sure that we're on the same page. You have said, and it's very. That seems like a very relevant thing to say. You said science is irrelevant if it doesn't prove the life of a normal person. I mean, I wouldn't
Yeah.
100% agree with that because that's pure science, but understand the idea, right? Think it's practical. Yeah, I mentioned practicality,
Right.
right? So I asked you what technologies, what things in the world, what things that improve people's lives is based upon your understanding. What things in the world, what technology, what things are built. And you said everything. So
Yeah.
that would include buildings, that would include computers, that
Okay.
would include airplanes. You said
Right.
everything.
Yeah.
So I
So if
picked
you want,
one thing
okay.
out of everything, and I'm
Okay.
asking you, how does this
How?
thing,
And
how
what
is
way
this
are those
built?
two things connected? Right. Okay. I
Yes.
got you. Okay. So when it comes to buildings, right, our buildings are powered by electricity. I mean, that's
No. I'm saying the structure of the building itself. I'm not talking about electricity. I'm saying you
right. Right.
build a skyscraper, it doesn't fall.
There were
How,
buildings around before we created like lights. That was early
I don't
on.
want to go into history. I'm
Well, I
asking,
don't,
how
but
is
you're
it
asking me
really
about
built?
something. But you're asking me about something that was already invented before. So obviously the idea of building a house doesn't depend on light because there were already houses by the time light was invented. So I'm not quite understanding your question.
Yeah.
But I will say
All
that
right.
the way that we use buildings today, though, right, those depend on electricity almost completely. You know what I mean? We need electricity, and like I said, the ability to send sound waves. Both of those things come from Tesla. Both of them.
Gotcha. Now, I remember you was mentioning that one of the guys, the two guys that you mentioned at first, uh, the two, I didn't pay attention to their names, but are they like physicists or
Are you talking about the Nobel Prize winner and the guys who work at the Princeton Institute of Advanced Study?
the one was on Lexus? So they like PhD physicists?
Yes.
All right. And one of them, you were talking about how quantum physics, that's going to be thrown out the door as well. It's not.
Yes.
You explaining all the different words to me. Let me ask you. And you were saying, like, electrons don't exist, and it's
Right.
movement and where things are.
Well,
So,
they're
like,
all just different. They're like I said, the paper example, right? They're all just different shapes on a paper. You know what I mean? It's all paper, but they're different drawings, different whatever. But in the day, it's just pencil on a paper.
okay. So if you have a particle, a subatomic particle, how do you, or how would you determine the amplitude of its location, and how is the way they're actually doing it wrong? Like, let me know
Okay.
how the way they actually do it is wrong, and then what's the real way it should be done, or the real way is really being done behind the scenes if we knew what was really going on.
Okay. So that's basically the first video, right? Okay. So let me see. Okay. So, all right. So And like I said, and of course, this is mathematically mainly, but what they're doing is they're creating mathematical models and then matching it up to what they see in the colliders, right? So the scattering amplitudes, right? They basically collide they collide the particles at each other, right? All right, so they collide the particles with each other, right? And then they examine, right, what it is that they see on these quote unquote subatomic levels, right? Then they try to match that up to what it is that we know
So
mathematically.
I'm not asking about that. I'm just saying you want to find the location of the particle, the most probable location of a particle.
Well,
What's the real way?
I think I understood your question. Let me just finish it, and we'll see
Okay.
if we're on the same page still, right?
Okay.
So when they do that, right, they assume location, right? They assume that, or just to make it simple, they assume that particles are in either one spot or that they're particles at all. You understand what I'm saying? They assume that the particles are in, like they assume location. Like if I'm shooting a particle, I'm assuming that when I shoot that particle, that's the only event that's happening. Like I said, as simply put, when I shoot a particle, I'm assuming that that particle being shot doesn't have any effect on all of the other particles, on the oxygen, on me, right? Every time I shoot a particle, I'm assuming that it's just that one particle being shot based upon our conception of space-time, right? Okay, so if they take those
And I want to be
assumptions
clear.
out, hold on.
When
If they
when you
take those
say they're
assumptions out,
assuming when you're saying they're assuming these things, are you saying that you read in their papers they're assuming this, or you heard them say that,
I'm
or are you
repeating to you
saying
what
they're assuming it?
I'm explaining to you what we heard in that first video. That first video, that's basically what the guy was saying is that based on the framework, right? Like, let's say I'm shooting an electron and a proton and a neutron, right? That's what I'm doing theoretically, right? So in my equation, that's how I'm going to map out the equation: one electron, one neutron. If they change it, right, and they say, listen, there's no electron, there's no neutron, it's just one particle, right, over a series of different shapes or vortices or movement patterns, right?
Mhm.
Let's make it one particle, like a net, if you will, right? Instead of us saying like I'm shooting a particle, maybe I'm just waving one big particle. I'm waving one big background, and the effect of the wave comes off as a particle. This is when you get the idea that particles are waves and particles, right? They say, think about it. This is my own interpretation, but this is what they're finding in like, they're like, when we shoot light beams, it's a wave and then it becomes a particle. We don't know how. Okay, well, maybe you're waving something and then it looks like a particle at a different modality, right? So that's what they're saying, that if we change the math to say it's not all these different particles, it's only one, or they say like sometimes they can, you know what I mean, they might get up to like 2 or 3 different, you know what I mean, vortices or movement types, right? But really they're like, on some instances, we can take 1 billion movements, 1 billion particles, reduce them down to one, and then the math is perfect. And it doesn't match what we would quote unquote see in space time, but it matches what we see in the collider, and it matches and the math matches. There's a parallel between those two. You understand? So that I don't know if that answers. That's like the long way, but it's like that's how, right? The idea of looking at everything as just one thing rather than looking at everything as all these different things, it works better from what they're seeing in the collider and their mathematical equations when they're trying to explain what they see.
Did I hear you say that light? Did you say light is not a wave or it's not a particle? What did you say about light?
Well, I'm
Either
saying
here
that
or earlier.
when they do the double slit experiment, that
Mhm.
was them proving that this is their explanation. Before we look at it, light is a wave, and then it only becomes a particle when we see it. I'm sure everybody's familiar with that by now, right? Because when they do the experiment and they get the interference pattern happens as if light is a wave. But then
Mhm.
when they're watching it, it acts like a particle, right?
Mhm.
So I don't know. I don't know if you know who Henry Poincaré is, right? But Henry Poincaré, right, or Henri Poincaré, however you say that dumb French name. He's the one that really that Einstein took the theory of general relativity from. He literally says it is not the universe that imposed space and time on us, but it is us that impose space and time on it. And this is congruent with what scientists are seeing in the subatomic particle colliders, right? They're seeing that, okay, these things act in a way that there is no space time. They're acting as if it's just one, basically, it's just one medium moving at different shapes and frequencies.
Okay. So what's really then going on with the photoelectric effect?
The photoelectric effect.
Mhm.
So you're talking about light then? So you're saying like what is light?
Okay. Well, why don't we put it another way then? What is it that's actually, so when you say light goes through the, when they watch light, when they see light, that's what causes it to act like a particle? What exactly is it? Are you saying that causes it to act like a particle?
Right, when they're observing the experiment. So the experiment happens, right, and then they can see the result of just to make it simple. Obviously it's more complicated than this, right, but this is the simply put. They run an experiment. After the experiment, there's a pattern on the back wall, right, of the experiment that lets them know what happened. So they can watch the experiment and then see the pattern, or they can not watch the experiment and just let the pattern happen. It's very simply put. When they do that, right, when they don't watch the experiment, but they just look for the pattern after, light acts like a wave. It's not a particle. And their explanation is that it turns into a particle when we look at it. They saying that light, they're saying that the particle is sentient. Do you understand what you believe in? Or not you, but the people that are saying that light is a particle.
So
They're saying that
let's see that.
the particle
Let's
is
see that
sentient.
then.
Hold on, let me finish this. Let me finish because this is
Okay.
crazy. They actually believe the light particle is sentient. It knows when you're looking at it, and it's like, oh, he's looking at me now, like the WB frog. They're saying the light particle is the damn WB frog. That's crazy.
Mhm.
More than
Okay,
likely,
so let's
it's
see
a
that
wave
then.
the whole time.
Okay, let's
But
see that then. Let's see the paper where they say that or at.
you never seen the double slit experiment before? I'll pull that up. I'll pull it up. Pull
No,
it
no, no,
up.
no. I'm asking. No, no, no,
Pull
no.
it up.
I'm not asking about. Wait. I'm not asking about the double slit experiment. I'm asking you to pull up where they say the light is sentient. I'm asking you to pull that up so we can look at that.
I mean, I'm not gonna do research on stream right now to find a paper where it says that. You either have to take my word for it or go prove me wrong later.
So let me make
But
sure I'm understanding
research the
properly.
I can show you the double split experiment.
Hold on, wait. Let me make sure I'm
You'll
understanding
see.
properly.
But this is what I'm saying. You'll see that in the experiment, at the end of the experiment, their conclusion isn't, well, it must be a wave then. That's not their conclusion. Their conclusion is, well, it's still a particle, but at some point in between when it shoots and when we look at it, it turns into a particle. So maybe they don't use the word sentient, right? But I'm saying that essentially that's what they're saying. They're saying it turns into a particle when you look at it. So either I have the
Let's go
power,
back.
I have the power to affect micro atoms of light to turn it into something. Either that's what you're saying, which is like you're saying we're in a simulation now. So basically, this is fully a simulation, if that's the case, or you're saying that the light beam is sentient and it knows when it's being looked at and it doesn't want people to see what it really looks like or something. It makes no sense. It makes no sense at the end of the day.
So to be clear, you saying you did not read a paper where they said the light is sentient.
No, I've never read a paper. I don't worship paper. Okay, I listen to scientists talk about their discoveries in their experiments. You know what I mean?
So
Yeah,
you
no,
heard a scientist say the
Huh?
the light is sentient.
Yeah. Well, no, I told you maybe they didn't use the word sentient, but they said
Okay.
clearly at some point between us looking at it, right, and it leaving from where it was shot from, it decides to turn into a particle before we look at it. That's what their official explanation is. Yes.
Sure.
Right. And you're gonna have to just take my word for it. All right. Go do your research on your own time. You feel me? That's why, like, dog, I literally spent all day today and yesterday. Well, I got a debate on Tuesday, so that's why I do that. But like, I've been reading and researching this all day, getting ready for it. You know what I mean? So, you know what I mean? It's like I can't, you know, it's you know, you got to do that on your own time, my brother. You feel me?
Okay. You have said that masses are attracted to the incoherent magnetic mass of the Earth.
Yeah, magnetic fields are attracted to incoherent fields, right? But the bigger the field gets, the weaker the attraction gets. So it basically, you know, like people say, like, well, if Earth is a magnet, right? Then how come when you flip your field to the other side, you don't fly off, right?
But I'm just saying, like when
I'm
I
seeing if explain
drop
that to you.
something,
Go ahead.
that's what's happening. So, but you don't have any equations or anything to calculate
No. We
uh
have
the
real
rate at
life
which something
experiments.
falls.
We have real life
Okay.
experiments.
Okay.
Yeah, real life proof and experiments that yeah.
So, so how do you suggests that uh, that the kinematic equations and things are able to do that, like able to calculate how long something will be in the air for, like a projectile, or how fast a block will slide down a slanted plane. How do you account for that?
How do I come to
Or
that?
are you aware of that that is a thing?
Well, yeah, that's what we were talking about earlier. I mean, they basically. This would just be me assuming because I'm like, this is what would make the most sense, right? That if you can basically calculate the rate of the rate of movement between magnets, right? An average rate of movement. Like you take 100 different magnets, right, that all have different strengths or whatever, and you take the average rate of movement, and then you create an equation from that. This is just me pulling this out of my ass. I swear to God. So I'm saying this would just make the most sense. I don't know if this is how they did it, but you could do it like this, right? Come up with an average of the rate and see how that works in place of quote unquote gravity.
Mm. Right. Well, I appreciate you speaking with me, man. It's pretty much all the things that came to mind. Like I said, I just want to get an understanding of a better understanding of why you hold your position, and I think I was able to accomplish that. Um, I'm fine if you before I go, if you want to ask me questions about something or anything.
Yeah. What was that? What was the first question I asked? I asked about you believing, right?
Okay, yeah.
Do you remember the question or?
Yeah, basically, do I believe in or abide by the mainstream idea of the way the world works?
Like,
Basically,
just to make it split, like, do you believe that just because it's in a peer reviewed paper that it's something that is accurate or is technically scientific? Like, what is your ideas about the scientific method?
okay. So, my understanding of the scientific method is basically this: people do research, do experiments, come up with theories that are then tested in various ways. They publish their results is subjected to the peer review, and the things that uh, withstand that test or become established laws. That's basically the gist of it. Just because something is in a paper, do we believe it? No, no scientist does that. That's why when somebody puts a paper out, people test it and try to disprove it. So things are only accepted after they are verified. Papers are not like a Bible in science.
Yeah, well, I mean, I'm not gonna lie. It seems like a lot of people treat it that way, because people have a very, very negative reaction to, I mean, me just bringing up simple experiments that prove something, and then when they're trying to debunk it, they never bring up experiments on the other side. You feel me? They're just always trying to poke holes in what it is that I'm saying, and I never hear like, okay, well, you know why that's wrong? Well, because look at this experiment, right? Here's this experiment of proving blah 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 blah. You feel me? Or if I bring up a quote of of Einstein saying his biggest mistake was throwing out the idea of the ether in general relativity. If I bring up a quote of him saying that, nobody ever says, "Hey, here's another quote of Einstein saying, hey, you know the other quote I said? Yeah, I was just bullshitting. I didn't really mean that." It's like I'm sometimes I get confused, right? When people get upset when I call them religious and I say that they worship paper when they clearly do. You know what I mean? Like I said, like think about it, all the experiments that I brought up, right? As soon as I brought up the or when you asked me about the papers and I brought them back up, you were like, oh yeah, let's bring the paper up, let's read it, let's see if it says what you were so interested in whether or not that paper said what I wanted it to say, as if that even matters. It's like, who gives a fuck? If it says it or it doesn't not, if it doesn't, it's a piece of paper at the end of the day. And if we are taking it as gospel, then now we're worshiping it like a Bible. You know what I mean? So I actually don't believe that peer review papers are number one, valuable, useful. I mean, I don't think that there's any credence to any form of appeal to authority. You know what I mean? So I get confused when people claim to be quote unquote scientific and they want to hold my feet to the scientific fire to the scientific fire, but at the end of the day they're just appealing to authority the whole time. What does this paper say? What did this person say about it? It's like, well, it doesn't really matter. Like, what does the data say, right? What does the data say? And then I want to hear different people's perspective on what they're taking out of the data, if that makes sense.
Here.
Yeah, I don't think man, it's crazy that this other video that I had was so perfect too. It literally like showed you step by step, like let me try one more search.
Okay.
I literally watch like 1,000,000 lectures a week.
Hit him with a hammer.
Either way, anybody listening right now, go look up incoherent magnetic fields. If you look up incoherent magnetic fields and you do just a little bit of research, all right, it's going to take some time. You're not going to be able to look at the first 5 videos or the first 10 videos. You're going to actually have to do some research, and you'll find some good content where people are giving you examples on how magnetic fields work on each other. And then when you group large fields together, they give you one second. When you group large fields together, right, they show you how certain effects would take place and how it literally looks like exactly like what we experience on the earth. See, this is my main thing is if you want to believe something about the earth, right, or about the stars, then you have to be able to replicate it in a lab, right? If you can't replicate it, then your opinion is not really scientific. You know what I mean? You know, so that's why, like, you know, when I was in the debate and you know, we were talking about matter of fact, that might have been the after show actually, but when people talk about stars and stuff, right? I'm like, okay, well, what are? I think that was during the debate. I'm like, okay, Leo, what is a star then? What do you think a star is? He starts explaining what it is, and I'm like, okay, well, has that been replicated in a lab? Has anybody replicated that in a lab before? No. Okay, so how do you know it's that? How do you know that's even possible? You don't know that's possible, right? Okay, so but when I say that everything comes from sound, right, and everybody gets all upset, right? Oh, what are you talking about, right? I'm like, yeah, everything comes from sound, right? Because everything is basically just light, condensed light, right? And then we can prove that light comes from sound, sololuminescence, right? So that we can actually get a jar of water, right? You can do this at home. You can use sound or electromagnetic frequencies, same thing, and you can shoot it at the water and you can create a star. You can create light that looks exactly like what it forms exactly like what we see in the sky. It's a mixture of water and sound, right? Okay, so if that's my hypothesis, right, and I have shown it in the lab, and you guys have a hypothesis and it hasn't been shown in the lab, I'm sorry, we got to go. We got to go with what I think. As far as I know, I'm the authority right now, or whoever is on the side of the people, right, that are appealing to experiments and stuff that we can actually replicate on Earth. You know what I mean?
But make sure I'm understanding properly. Your position is that stars are light and sound because of that.
I'm saying that everything, well, and sound is just another way of saying electromagnetic frequencies or energy, right? It is. It's just frequency and energy. And so, yeah, I'm saying that like everything that we see is essentially condensed light, right? That's why they don't know, right? I mean, like I said, the particle colliders are proving some of this, right? But everything that we see is essentially condensed light, right? And when you get all the way down to what light is, you're going to just start to see different strings of electromagnetic frequencies, which essentially is the same thing as sound. You know what I mean? Like your body, right, is essentially just one big electromagnetic field. You're like you know how people say like we're vibrating over and over. Think about it. To say that something is vibrating is the same thing as to say that something is making a sound. Making a sound and so you're just one big sound. We are just one big sound. I mean, like, this is heavy stuff, but it's like we're a frequency. We're a certain you know what I mean? We're a certain tunage or whatever, or what we describe as tunage, because that's just our basic Neanderthal way of understanding what we're seeing and what we're picking up. It's just our user interface. You know what I mean? It doesn't say anything about what's really going on under the hood. God dang it. How can I not? Like, I swear to God. Anyways.
No problem. Well, it was nice talking with you, man. I appreciate you taking the time to speak with me.
Yeah, I appreciate you too, man. And like I said, man, you're more than welcome to come on anytime. You feel me? I always like to invite people to come on and challenge my opinion, whatever it is, that they can, especially if they've proven that we can have a cordial conversation. You know what I mean? So I do
I
appreciate
appreciate it.
you. Yeah, I do appreciate you being so inquisitive. I like how slick you were. You feel me by avoiding most of my questions. You know what I mean?
Well, hold up now. Let me know a question I avoided. Like I said, when I said earlier, let me know any questions you had before I go. I didn't want to be just here, just ask you a bunch of questions and then leave without you having. So you asked me about what I thought about science. I answered that. What other questions did you ask me that I didn't answer?
Oh well. I mean, I mean, I mean, just building upon that, right? Now, when you look at so do you believe that if there's an experiment that shows that something is possible, right? In order for you to assert that something else is possible, do you think that it needs to be shown through experimentation?
Give me a specific example so I can understand what you mean.
Like the star example, right? Like if you say stars form because of gravity, and I say stars form because of sound, right?
Mhm.
And I show right through in a lab that stars can come from sound, and you never show, or if I show that stars can come from sound, in order for you to challenge my scientific theory, do you have to show in a lab that stars can come from gravity?
Okay. Well, perhaps it's my fault that I didn't give as much attention as I should have to what you said about that. Okay, so the lab showed that stars from sound. So
Yes,
the
that
particular
it's
star that
possible.
was made, it's possible. Okay, the particular star that was made, uh, what was what was the spectroscopy on the light that came from that? Like what elements were in that star, and what was the concentration?
I'm gonna pull it up for you right now.
Okay.
Sonoluminescence.
The first time I saw sonoluminescence was in a darkened room.
Yeah, so this is it right here. Right.
Seth Putterman called it the star in a jar. A tiny.
Okay, so basically, right. So when we look up in the sky, right, we have no idea what we're looking at, right? Because we're down here. We've never been up there. Oh, I got another question for you too, since you used to work for NASA. So
Oh,
we've
let me
never
be
been up
clear.
there.
I don't want even to be mistakenly misrepresented. I never worked for NASA.
Oh, okay. Okay.
I was a community college student, and I was in the INCAS. It's called. So let me just give a bit more detail on that, so there's no lack of clarity. So
Right.
if you're a community college student, you can sign up as for this little program that they have, where you can learn. You can spend a few months learning about NASA. NASA people come and speak to you, but you're a community college student. You read some things from NASA, hear some things. If you pass the first section of it, then you can join the second session where basically you do this mock project where you plan a space mission. We plan a space mission to the moon. It's sort of like a game, and doing at the same time you're working with other students, and you end up presenting your project to some NASA people at the end. But it's basically a way for community college students to learn about NASA and potentially help them become an intern if they want as a NASA. But I was a community college student. It was sort of like a not really intern, but I guess that's the closest I can relate it to. It was a learning experience, but I never worked for NASA. It would be nice if I did, but I never worked for NASA. So I don't want to anybody to think I misrepresented that.
Okay. Sorry about that.
All right,
I
no problem.
I stand corrected. But like I said, so if we look up in the sky, right, we have no idea what we're looking at. All we see is lights in a medium that we have no idea what it is. So if I can recreate that, right, I'm saying that is what I've recreated right here, right?
Okay.
And you say, no, that's not what it is. Do you have to be able to recreate that in order to challenge my scientific theory?
Well, I'm still at the point of trying to understand if that's what you recreated, right? So in other words,
I mean, as far as we know, like visually, it is because we don't know what the stars are. All we know technically is that they're lights.
okay. So in other words, then what is wrong with the spectrometric data from stars. I don't know the proper adjective. But so how is that wrong? The data from spectroscopy about the elements in stars, how was that wrong? And how did you recreate that, or what elements did you find in this light that you saw?
Well,
Either how is that wrong, or
it's
what
all
elements did
theoretical.
you see in this?
It's all theoretical because you can't collect particles from something that you've never been there. So it's literally just all theoretical. People are just
It's
claiming
all
that.
theoretical.
Yeah. Yes.
So what is really going on then when you send energy into, let's say, a lamp full of hydrogen? What are those lines that you see in the diffraction gradient? What is really going on there?
Okay. You're saying when you send light in.
If you have an electric lamp of hydrogen, for instance,
Okay.
and you look at it through a diffraction gradient, and you see the spectrographic lines, what is that? What's really going on there? If it's all just theory, because obviously what they're saying is going on can't be real. So what's really
I'm
going on there?
I'm saying that everything is just different electromagnetic frequencies interacting with each other, and as they take
I'm
different
asking a
shapes and
very
forms,
specific question. I'm
I'm
asking a
telling you,
very
I'm
specific
telling you what
question.
my answer is. As they take very specific forms and interact with each other, they change shape, which codes, right? Like the guy said, these different shapes become coding for locality and basically how we identify things, right? We see things at certain places in certain shapes and at certain colors because of the certain frequency that they're on. So I'm saying all we're seeing is changing in
Okay,
frequency.
okay. So what colors and what lines did you see from the light in the draw there? What lines were emitted from that?
What lines were emitted?
What spectrographic lines were emitted from that?
I can't answer that. I don't know.
Okay. All right. So the spectrographic lines that we do get from stars, you're saying that's just is not really elements. It's not. We're not seeing the light from the elements in the stars.
I'm not saying that anything that we see is not there. I'm just saying that what they're describing it as is obviously not what it is. And if it is, then shouldn't we need to see some experimentation that shows that in order for it to be
Well,
scientific? It can be a good
I guess
theory.
this is what I'm trying to get at. Were you able to get a spectrographic series of lines from the star in the bottle, just like how we can get from the various stars? Were you able to get that or not?
No, I didn't run the experiment, so I can't answer that specifically. I don't know.
Were they able to get that?
You'd have to go look that up for yourself. Yeah, I don't know. I mean,
So you,
there's
so
like
you don't know if they were able
there's
to get
hundreds of
that.
different times that experiment has been done, so it should be easy to
Okay.
find that information. Yeah, I'm not sure.
Okay, you're not sure.
No.
Were they able to see activity on that star in the bottle, like sunspots or sun flares, similar to how we see on the sun?
Sunspots or sun flares?
Hmm.
I don't know about sun flares. I don't know if that's confirmed or not. Because as far as we
Solar
know,
flares.
the sun is basically just like a lamp. The sun is just a light in the air. Like we've never been on the sun or anything.
So you're saying there's no such thing as solar flares?
I don't. It depends on what they're trying to say that it is. I don't know enough about solar flares to
Okay.
break down what it is that they're talking about in plain language. Because I like
Okay.
people have jargon, right, to
No problem.
explain things. Everything
Is,
really is simple. So I don't know what the
is there such
jargon
a
is.
thing as sunspots? Is there
Sunspot.
such a? Mhm.
So you're saying like when they take a picture above the earth, how the sun is pointed on one spot?
No. Okay. So what I'm understanding is that you did not verify that the thing in the jar is the same thing as what we see in the star. So that means that the question that you
Well,
asked
well,
me is
well,
not a
well,
valid
well,
question.
well nobody can verify that because we don't know what it is that we see in the stars. We don't even
No,
know
no,
what that
no,
is
you're missing it.
to
No, you're
verify.
missing it. You're missing it. I can look up. Do you agree that I can point a telescope at the stars or at the sun and look at them, and I see something?
Yeah, you see a light. That's it.
Have you ever looked through a telescope at the sun or at the stars?
I have looked at a telescope at sun, stars, and planets. And those planets, like if you look at planets through telescopes, they don't look like what they tell us stars are at
No,
all.
no. So you looked at the sun through a telescope?
I don't know if I've looked directly at the sun through a telescope. No, I look at the sun every day though. I'm a solar gazer, so I look at the sun
Okay.
every day.
And it's just the light.
Huh?
and it's just a light.
I mean, apparently, right? It's the same
Right?
thing. Like think about it. Like the sun is the same. It has to be literally the exact same baseline substance that these lights are, right? The lights that's shining on me right now. You know why? Because if I took a plant, right, a baby plant, and I put the plant in here under the light, the plant is going to grow exactly like it would under the sun. It gets the same energy from this light that it does from the sun. It doesn't, whatever they say the sun is, right? Fire, gas, or all these things. I could take those things and put them next to a plant. The plant's not going to grow from that. So how could the sun be that if the plant doesn't grow from that? The plant grows from the sun. Electricity, because the plant is electricity. So the plant needs more electricity in order to get energy, just like us. Everything is electricity. So electricity comes from this light. That's why the plant can grow from this electric light. Electricity comes from the sun. That's why the plant grows from the electric light that is the sun. Whatever the sun is, it's electricity coming off it.
All right. Well, let me just make sure to wrap it up so it can be clear that I tried to address your question, but what I'm seeing that's causing the question to be an invalid question is if I'm going to say, okay, you created a star in the lab, so now you have to recreate what I see out there in the lab. You haven't shown me that you created a star in the lab because you don't even know the characteristics of stars to even know if it was a replication of a
Right,
star
right.
in the
I
lab.
agree.
So
We're
you
just
can't
going.
really say that you created what we see in the telescope in the lab.
I
So
mean,
do you have any
it's a
other
lot
questions that I
closer.
that I missed there?
Well, no, yeah, but it's a lot closer than anybody else has been able to create. Nobody's even come
You,
close to being able to create anything that looks like what we think the stars are. So we don't know what it is.
okay,
You're right, but at least visually, I can at least create something that visually represents what we're seeing. There's on the other
interesting.
side, there's not even anything that visually represents it.
Okay. So since you were able to create something that visually represented it, what were the frequency of the sunspots on the star in the jar? And what was the direction of rotation and the rate of rotation of those sunspots and the frequency of how often they came about?
Yeah, I'm not sure. If you want, I can do some more research and we can dive deep on that next time. I would have to read
All right. So that
specifically
means
on
that
that.
so that means that you can't say what you just said. You just said you
I
created
can
it, but
say
you,
it.
you
Well, I asked you a question because at the end of the day,
and
the
I
question was
apologize. When I say that you can't say it, I mean you can't reasonably
asserted.
say
Yeah,
what you
I
just
get what
said
you're saying.
because
But,
you
but,
because you
but
don't have any basis to say that.
right, well, but it was just a question, right? So I'm saying if, right? 'Cause I'm not saying we can't, because even if we could prove, right, that we created exactly what the star was, that doesn't mean that that is how they were created. Just because I prove that it's possible, that doesn't mean that that's the process that took place. So even if I could prove that, it's still not evidence. So I'm just asking if, right? If I theoretically, right, could do that, right? And you're saying that no, I think it's this way. Does there need to be an experiment on the other side for you to even have weight to be able to disagree with me scientifically, or no?
I think if you created a star in the laboratory and based upon your understanding of what things are, then that would definitely bring up some questions. Yes.
Okay, okay. All right. Last question before I know you got to get out of here. Um, do you actually think we went to the moon? Well, okay. First of all, I want to preface it by saying, because a lot of people don't know this already, and I got to bring everybody up to speed. Let's not argue over the facts. All right, the facts are NASA admitted that they faked the moon landing. All right, let's be clear. That doesn't mean that they did not go to the moon. For all you guys listening, that does not mean they didn't go to the moon, but it does mean that they did fake the moon landing. They admitted this. All right. They like the Chili Pepper said, space might be the final frontier, but it's made in a Hollywood basement. All right. Sorry. They admitted that already. So since we know that they admitted that they didn't go to the moon, do you or excuse me, that they faked the actual footage of it, do you think that they actually went to the moon?
Well, I guess when I think about whether they went to the moon or not, the first thing that comes to mind is the reflector that's on the moon. So the reflector was put there, it's being utilized by people, so that tells me that they went to the moon.
I hate to do this to you, my brother, but how do you know the reflector's there?
All right. I know that flat earthers are
I'm not a flat earther.
very big
Continue.
about uh, 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 it seems like the thrust of your position is simply trying to sow doubt. I don't really play that game.
Trying to do
People
what?
just I don't really play the game of how do you really know it's there, and they're so in doubt and
Well, you've been
distrust.
doing that to me
I
this
don't
whole
really play that
time.
game. In what way exactly?
Isn't that what you've been doing to me? Well, how do you know for
Oh
sure?
no,
Does the paper really say that? Well, let's pull the paper up. We sat here and read the whole paper.
no,
Like,
no, no, no.
I'm
I
confused.
let's compare. You had said they created a star in a jar, so I asked you details about that. Okay, you
I was
said
asking
this
details
paper
about
supports what you said. Asked you details about that. That's totally different from saying, well, how do you really know that they went? That's sort of a
how is that,
do you really
bro?
believe them?
How
That's
is that
totally
totally?
different.
It seemed like you said the same thing to me. You asked me details. I'm asking you details. What do you mean they have a reflector up there? How do they know that the reflector was up there? How do they know? That's all I asked. And you see this, but this is back to my point about you guys always, or not you guys, but people pressing me to be scientific. But then on the other side, they don't want to be scientific at all. You just want to take
This is what I mean.
appeal to
Th-
authority.
This is what I mean. If I say I talked to somebody who shot a beam to the reflector, well, how can you believe them? They could be lying. How do you know that the system wasn't fake? There's no end to that. That's totally
There
different
is an
from
end to that. I disagree. I
there's no
think
end to that.
the
I
end.
don't
You
think
know what
put
the
it
end
like this.
is?
I don't see an end to that.
The
I don't see an end to that.
scientific
We can disagree
method.
to
No,
disagree.
dude, the scientific method is the end of that. That's why I always am stringent on not considering anything science unless it follows the scientific method, because those are our checks and balances. If you say something happened, right? Think about it.
Mhm.
Even if you do an experiment and you come up with a theory, you know what the end of that is? It has to be testable and repeatable. They always forget that part on the debates. Where is the repeatable? Huh? Where is the repeatable? If you do an experiment and you want me to believe you, I have to be able to do it too. And don't tell me it's too expensive, because now you bullshitting. You lying. You lying now. Yeah,
Interesting.
that's right. Life is not so complicated that the average person can't understand what people are doing scientifically. It's really not. All right. So look, if there's an experiment, then I should be able to do it too. And if I can't, then as far as I'm concerned, y'all lying. It's not scientific. So that's how you end that. Oh, you don't believe me? Well, then do the experiment yourself. That's how you end it right there. That's why in my debate, I said, look at this experiment you can do with this telescope. Boop. You can do this experiment at home. Look at the Michelson and Morley. That experiment is a little bit more expensive to do, but it's been done so many times that, like, go look at all the people that have done it. I'm sure that you can go find a college lab, right, that has the equipment that will allow you to do some basic laser interferometry experiments. It's really not that difficult. All these things can be done. But on the other side, there's never a call for an experiment. There's never like, well, look at this observation. Look at it. There's never that. And then when I say, okay, they said this, well, how do I know? And now you're like, oh, well, I don't want to do all the I don't believe you thing. Hey, don't get me wrong. You a slick brother, you feel me? But I'm slick too. All right, I caught that. You feel me? I you know what I mean? You trying to run the game on me. You feel me? Trying to. I know you. Yeah, you trying to run a game on me. Anyways, man, I'm like I said, I'm not gonna press you too hard on that, but because I know the answer to that question already. Like I said, the answer is they don't have anything on the moon that they're receiving back. They say that they have. I can't think of the name of the quote unquote. I think it's something Debbie Center that they say that they're getting info from because it's floating around the sun. But then when you look at all the readings, they're not getting any readings from around the sun. All the readings that they're getting are coming straight from Earth or in upper or Earth atmosphere from their satelloons or from airplanes and stuff. Anyways, all right. So I'll start you out on the moon thing, man. Like I said, you know, and even then, even if what you said was true, that still is not proof that we went to the moon. I mean, even if we did put something up there, right? All that's proof that maybe we shot something up there, right? Hey, maybe we shot the thing up there, right? And right. So there's a lot of other options besides us having been there ourselves from something being on the moon that we can receive frequencies from. You know what I mean?
You're right.
And like I said, man, I do.
Any other questions I missed or didn't answer or something?
No. You good, brother. I honestly, I appreciate you, man. Anybody who's ever seen any of my content, I'm sure that they know that this is probably the comments that I've ever been, and that's 100% a result because you've been 100% respectful the whole time. You know what I mean? I tried not to interrupt you. I don't think you've interrupted me one time. You know what I mean? And so that's what I'm saying. Like anytime you want to come on and challenge me about anything, you're more than welcome, man, because I can tell that you're genuine. You don't take what I say personally. And I can sense that, you're at least willing, what I mean, to admit that you might be wrong. Even if you don't think you're wrong, you're at least willing to admit that, okay, fine, if I am wrong, I'm at least willing to accept that I might be, so I can see the other side. Whether you agree with me or not, I can sense that genuineness in you. So I appreciate you. Like I said, you're always invited on, my brother.
Thanks, brother. Thank you for the welcome, and I appreciate being here.
Hey, of course, man, and I look forward to hopefully chatting with you again, man. You know what I mean? Like I said, like these are subjects that I know intimately. A lot of them, I haven't like looked at in a while. Like the gravity thing is like it's something that I started researching right out of college. And so, sometimes I have to go back and brush up on a lot of the stuff that I read, because I might have read it 1 or 2 times, and just the key pieces of the information are in there. You know what I mean? Like when you ask me specifically about, the details of how they created the star, is like I don't remember every single detail. I just remember that they did this, boom, boom, boom. And so I would have to go back and read up on it, specifically to answer a lot of those questions. You know what I mean?
Okay, sounds good. Yeah, when you get the information, let me know. I could come back.
Yes, sir. Yes, sir. Yeah, we'll be in contact on Instagram. You feel me? So, you know what I mean? Once again, thanks for coming, bro. And, enjoy the rest of your day, man.
Sounds good. Be cool.
Yes, sir. All right. Shout out Daryl. That was actually very, very, very respectful. See, look, this is, even though I'm super aggressive, like look at how 2 men can sit there and talk and not, I don't think anybody raised their voice except me, of course, but my voice is just loud. You feel me? But like, we didn't have to raise our voice. We didn't have, you know what I mean? Because like there was a mutual respect where he understood that he doesn't have to agree with me, right, to accept that what I'm saying might be true. All right. That is the key to intelligence, right? Can you accept that what somebody is saying might be true without agreeing with it? All right. So I'm gonna do a debate review of my debate eventually, but I got a debate on Tuesday, right, with McToon. So I'll be posting a link to that on what's today, Sunday? It's supposed to be on, so probably tomorrow, right? I'll be posting it up tomorrow, and me and him are going to debate kind of on this subject. So I was actually really happy that Daryl wanted to do this today, because it gave me a chance to run through some of my notes that I've been preparing, getting ready for McToon on Tuesday. You feel me? So definitely tune in for that. And if you guys have any questions or whatever, you already know, you can definitely, hit me with the questions. But I'm coming back with it. You feel me? So let's see. Is there anything else? I think that's it for right now. All right. So a bunch of other people have been in my inbox trying to schedule debates. So if you do want to debate me about one topic or another, you can hit me on YouTube, but it's better if you hit me on Instagram, because I get the notification right away on Instagram. On YouTube, I got to remember and go back and look through it. So if you want to debate me on any topic, especially on some political topics, just at least give me like a day or 2 notice. And usually it got to be between Sunday and Tuesday, because Wednesday through Saturday, I'm busy as hell. So Sunday through Tuesday, if you want to debate any topic, hit me in my inbox and I will destroy you. All right. I will massacre you. All right. That's crazy. I didn't even, you know what? Like I was saying, this dude was so respectful. I didn't even get to hit him with the Jesse one time. I swear to God, I was finna hit him with the wonder. I was planning on hitting him with that the whole time. As soon as he said he wanted to, yeah, as soon as he said that he wanted to debate about gravity specifically, I was like, wonder. I'm like, come on, dog. I'm like, gravity is a cooked turkey, man. I'm like, this is old. It's 100 years old already. We're done with gravity, dog. I'm like, nigga, I could debate gravity in my sleep. I could literally fall asleep and like that's what I'm like. I just start off with those 2 quick videos. Like, look, these are 2 physicists right here, not even just debunking gravity. They're debunking the things that gravity stands on. Dark matter, done. You feel me? Space and time, done. Like there's like, cut it out. Everything is electric. Everything has an electromagnetic a reaction to each other, and that's how things move in relation to each other. That's the kinetic relationship. I don't know if I said that right. That's the kinetic relationship, dude. Thank you. I'm like, dude, gravity. I'm like, I could debate gravity in a coma, like for real. Like it's so done already. So anybody saying that gravity still exists or that gravity is mass attracting mass, wonder. Even if you say gravity is the bending and warping of space-time, dark matter has been disproven. Wonder. Space and time have been disproven. Wonder. These are 2 conceptual abstractions that you cannot assign physical properties to. All right. Anybody with their brain turned on knows that. All right. So, you know what I mean? Like I said, shout out Daryl again. I will be doing this. I will be doing this again, pretty much this same topic with McToon on Tuesday. So hit me in my inbox, hit me in the comments if there's anything you want me to talk about or come on before then. I don't think I'm gonna have time to jump on before then because I'm gonna be studying because I'm really trying to I'm trying to come ready. You know what I mean? Like I really want to have all my T's crossed and my I's dotted. All right. So I love you guys. I'll see you next time.